Humans, we all know, have been burning wood for a very long time. To cook things, to light things, and to make things. But then it was around 250 years ago some clever people invented the modern engine using coal, oil, natural gas, and very quickly engines replaced animals, engines replaced sails, engines helped light cities, engines gave us factories and highways and traffic jams, and every time we burn coal or oil or natural gas in these engines, carbon dioxide molecules escape into the air and hang there. See this, not without a microscope, but if you were to look up at a little clump of air, I mean really, really little, it's just only 1 million molecules of oxygen and nitrogen, whatever's in the air, these days you would find 412 CO2 molecules zinging about in here, 412. 250 years ago, there'd have been far fewer, only 280. 1,000 years ago, it would have been again 280. 10,000 years ago, once again, 280. For most of human history, 280 was the number, and the change when it came suddenly and not surprisingly right here around the 1760s, the dawn of the age of engines. That's the moment when levels turn up and up and up because carbon engines spread so quickly, first across Europe and America and Japan, and for centuries richer nations were by far the biggest users. But very recently, people who had been poor, especially in China and in India, they're catching up. Now they can afford more good stuff, and because there are so many people in those places, every little economic improvement has had an enormous compounding effect. So the CO2 count has zipped up to 412, and it's still rising, and that is not good. Because remember, CO2 is a greenhouse gas. Each one of these molecules can trap a little bit of heat bouncing off the Earth, hold that heat in place for hundreds, even thousands of years. So the more molecules there are up there, the more heat gets trapped and the warmer our planet gets. We know our planet is getting warmer. The real question now is how warm will it get? And one way to find that out is to go backwards in time to see what it was like the last time the Earth had CO2 levels in the 400s. So here is a history of CO2 levels going way, way back. This is going to be like, this is 200,000 years back. And if you look at this, at no point did CO2 levels ever reach 400. It's not even close. Okay, so let's double it. Let's go back 400,000 years. Again, it's nothing. Okay, 800,000 years, same thing. We would have to go, hello, you ready for this? We would have to go 2.5 million years back in time to find the point when CO2 levels were as high as they are today. 2.5 million years ago is what we call the Pliocene. And in that era, the Earth was, we know, about 3 or 4 degrees warmer than the Earth today. There were small forests not too far from the South Pole. There were hardly any glaciers. And the oceans swelled. Sea levels rose and rose and rose until they were about 55 feet higher than they are today. 55 feet. Back in the Pliocene, climate changes came slowly, sometimes taking thousands of years, and creatures had time to adjust. But now, changes are so sudden and so drastic, with so many engines still burning carbon to make, well, whatever, stoves, refrigerators, toilets, washers, dryers, cars, new things, cool things, better things. All those engines cut down the time we have left to adjust and bring us closer and closer to irreversible tipping points, where we no longer have the power to slow things down, where we can't control what's happening. There are regions on Earth, vast and important, like the Amazon rainforests, the Siberian tundra, the ice fields of Greenland that are getting increasingly unstable as it gets warmer. The ice in Greenland has been melting so fast that on a single hot July day, the melt was big enough to cover the entire state of Florida in 2 inches of water, which is not good, but it's still reversible. If we quickly cut down emissions now, scientists say that we can slow the melt way, way down. We can give ourselves a few hundred years, maybe even a few thousand years. Yeah, 1,000 years to cope and adjust. But if we keep letting things get warmer, at some point, and we don't know when, which is a big problem, Greenland ice will hit a physical tipping point and the glaciers will collapse in on themselves automatically. No way to stop them, no way to slow them down. Even if carbon emissions go to zero, the process would still be irreversible, and oceans all over the world would swell and swell and swell. And there are now signs, says a new study, that this might happen even in this century.
Because the more carbon engines there are, the less time we have to protect ourselves from runaway global warming. Engines really aren't our problem. We like engines. We need them. We use them. They make life so much easier. It's the carbon that powers those engines. That's the challenge. Keep the engines, lose the carbon. And that way, maybe we can slow the changes down that are coming our way and try to keep the natural world more like it was, well, when you were young. And if we're lucky, the way it might stay, at least for a while, even for you.